The integral of the square root of 1 minus 2x is a simple u substitution problem. A rule of thumb is to let u equal the inside function, which in this case is 1 minus 2x. And if we do that, the derivative will just be negative 2. And if the derivative is just a constant factor, that'll make it really easy. So we let u equal that inside function. Differentiating both sides gives us du equals negative 2 dx. We don't want negative 2 dx. In our integral, we just have dx. We don't have a factor of negative 2. So to fix that, we divide everything by negative 2. And we find that 1 over negative 2 du equals dx. Now we can rewrite the integral entirely in terms of u. The square root of 1 minus 2x is the square root of u, and dx we can replace completely with 1 over negative 2, which is the same as negative 1 over 2 du. Then we can factor the negative half out of this integral and rewrite the square root of u as u to the 1/2. Now it's a simple power rule problem. To integrate u to the 1/2, we simply increase the power of 1/2 by 1. So we go from 1/2 to 3/2, and then we have to divide by that new power. So we have to divide by 3/2. But dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing by 3 over 2, we can multiply by 2 over 3, and then add the arbitrary constant. Finally, negative 1/2 times 2/3 is negative 2 over 6, but that's the same as negative 1 over 3. And then we can just replace u with what we set it equal to. U is 1 minus 2x. So u to the 3/2 is 1 minus 2x to the 3/2, and then add on the arbitrary constant. And that's the integral of the square root of 1 minus 2x. Negative 1/3 times 1 minus 2x to the 3/2 plus c.